Like, what are the agents? Probably can you give us a couple of examples of like how they can actually solve the human problem?
When you have a task and you let the large language model do planning on that task, right? Instead of an algorithm where you say do step A, step B, step C, you have the large language model do the plan.
How do you define AI?
Now, what's really AI is going to be intelligent agents, right? Can we build agents that traverse all of our networks, gather the information, bring it together, and work on a problem on its own until it comes up?
Would you say this is mimicking the human brain, the way we have synapses and the connections between them, and the closer AI gets to mimicking the human brain do you think that's the ideal definition for
For
AI?
every neuron, we have 10,000 connections, right? Almost all of the knowledge graphs that I work on, each vertex has about 5 relationships, right? So 5 connect relationships versus 10,000, radically different. By the way, most of those are very weak links, right? And they're not hard links. And then also voting on where it is in the abstract models. Our brain has all these abstractions of models. I would say today's neural network is not anywhere close to that, right? It's inspired by it. We call it brain inspired.
Brain is very, very energy efficient, I guess, right? Compared to all the neural networks.
Oh my God, yes. 20 watts, right? If you think of a very, very low powered light bulb, 20 watts is about what our brain uses.
Hello, everybody. Welcome to our podcast, Everything Product. Welcome to yet another exciting episode. Today, we have Dan McCreary, a true veteran in the field of generative AI. So Dan's journey in GenAI began long before it became a buzzword. So as the current head of artificial intelligence at TigerGraph and former distinguished engineer at Optum, Dan has been at the forefront of AI innovation, shaping the very landscape we operate in today. In this episode, we'll tap into Dan's wealth of knowledge. So we'll go through and understand the evolution of AI, practical strategies of integrating GenAI into your products and processes. What are the most important AI concepts that are needed for product builders and business leaders? So whether you are an AI enthusiast, a business leader, or a product builder, this conversation will act like a generative AI 101 to you. So please stay tuned to the end of the episode, and thank you.
Hello, hey Dan. Welcome to the podcast, and we are privileged to have you on the podcast. Everything Product here. So why don't you, give us a quick introduction about yourself and what got you interested in AI?
Sure, I'd be happy to. Well, my background is kind of a solution architect. Ever since I was young, I really loved to understand how computers work, and I developed this odd interest and curiosity about intelligence and the brain. And so I've always kind of wanted to merge those things. In my early career, I was a chip designer. I really tried to understand deeply how integrated circuits work and how we could represent knowledge in data structures. And that just kind of evolved into a career really focusing on the different types of way we represent knowledge. I wrote a book called Making Sense of NoSQL. NoSQL is the types of databases that tend to scale out at a massive scale better. And I was very fortunate to work for a lot of very high-tech companies in the Bay Area. And I just recently left United Health Group, where I was head of their Generative AI Center of Excellence. And I managed a lot of the knowledge graph projects there. I think we built the world's largest knowledge graph for healthcare. So a lot of very cool things kind of related to the way we represent knowledge in AI and other areas of generative AI.
Yeah, that's awesome. And, Dan also has been in the generative AI space before it was a buzzword. So how many, right, 12, 15 years of experience in that area, Dan?
Well, I have always been interested in language. So I worked for a company called Syntactica that did nothing but language studies, and they built tools that would parse language and analyze them and find parts of speech. And a lot of it was search enablement. I worked for MarkLogic, which a lot of their things was search and natural language processing. One of our partners was SmartLogic that did search enablement, building search on top of ontologies and taxonomy. So search has always kind of been a key piece of that. I think a lot of my curiosity went back to the original Google article in 2012 called Things Not Strings. Rather than just matching keyword, match the concepts. And that takes a little bit of extra work, but if you understand those things, those are kind of the same things, same technologies we're seeing today in large language models in their attempt to build what are called embeddings for concepts. So you can find similar concepts very quickly using lots of complex mathematics. But the net result is that these large language models are really good at finding similar things and matching questions to answers in chatbots.
Yeah, and it's like a such a big of a buzzword that every product manager wants to integrate this or kind of learn about it. So I want to understand, right, like what is your view of product managers integrating AI into products, and can you tell us about your philosophy on how people can get comfortable with AI?
Yes. Well, first of all, I'm a very, very strong believer that product management is a super important role in many organizations today. I think it's very underappreciated. I didn't really realize what product managers did when early in my career I worked for Steve Jobs. And I think Steve Jobs
Right.
was probably one of the greatest product managers ever. He had a combination of skills of trying to understand the future, where the future is going, and building things that people really were passionate about, and being a leader and rallying the troops around it. Product leadership to me is creating a crystal clear vision of the future with people using your products and having their business problems solved. And great product managers need to think of how Steve Jobs looked at the world, saying, we're going to create these products that people are going to love. It's not going to be easy. It's going to be hard. You have to coordinate lots of resources, but you have to constantly overcome obstacles to get the right things in place for the people to be productive. And generative AI is no different than that. Generative AI is a huge, complex topic. There's so many different paths you can take, and many of them are dead ends, right? So you have to learn how to spot those dead ends early, and yet trying to guide your teams into business value. And then once you get there's a magical thing that happens when you're building a generative AI product. Let's take, for example, a chatbot. A chatbot, if you can only get 10% of the questions right, people are going to try it and then they're going to stop using it, and you're not going to get any feedback. But a really interesting thing happens at around that 30% mark. But once you get about 1 out of 3 questions right, people will say, well, it's a little more work to get it. You get some wrong, but I'm going to at least try this rather than picking up the phone and calling somebody. And once you get 30%, people are going to start to give you feedback about the way they ask questions. Now, those questions can go on to a log file. You can take those answers and questions, figure out which ones you got right, which ones you got wrong, start to group the questions that are most frequently answered incorrectly, and then focus on building tools so that they get answered correctly. That's kind of called Pareto analysis. It's not solving all problems at first, but focusing on the most common questions that are asked. And a good product manager has to understand that what we call the AI flywheel, right? The flywheel is try to build a chatbot, get some question answers out there, get the feedback from your users, always have that like and don't like button. Take the questions that you're not getting right, use that as more data, and then go around that circle. And then you get this virtuous cycle that happens. And a good product manager has to know it's hard to get to that 30% range. But once you do, you're going to build a product that really drives itself. And that's what the product vision has to be, is to get to that 30% level.
Yeah, that's true. Actually, I have a question on that. So I'm actively working on building a chatbot. Like it's great you brought up the topic. So and it goes back to the thought process, right? We wanted to incorporate generative AI into that so that customers can easily come. Our bot can easily understand all the questions they're asking, respond to it as much as possible, so that the load on our support teams or operations teams reduce this as much as possible. And I don't think we are there at 30% yet as well, but we are trying to reduce as much tickets that comes on staff. So taking back on the exact same example, right? I want to go a little bit more deeper. So, how do you think about incorporating AI into it? Like in a general chatbot principles, it's 100% right. We train it to say, hey, these are the types of questions, these are the type of answers. But once AI comes into picture, it could go haywire. Like, how do we think about incorporating AI into it?
Yeah, well, the way I like to start out by thinking about that is very often when you first start out building a chatbot, you have an existing knowledge base, right? Maybe it's a call center. People call in and you train your call center agents and you give them the book of knowledge and you say, here's the training program. You go through training for a month or two. They learn and memorize them. They listen to calls and eventually they know the answers to those questions. It's in their brain. The first step is you take that knowledge book and you break it down into question and answer pairs. And that's often your first thing. But the way that people ask questions, sometimes it won't match the keywords in your things. So that's why we need to use these tools to find what's called the underlying intent. Project managers have to understand that intent is what you seek, but the keywords is not what you need to match. You need to understand that intent. So you build what are called intent models. What is the intent of this question? I come up with examples in healthcare a lot because I worked on call centers in healthcare. People might say, we just had a new baby. What's my benefit plan? We just had a new child. What's my benefit plan? We just had a new infant. What's my benefit plan, right? Different words, they all mean the same thing. The same underlying intent is there. And so chat bots are effectively need to be designed to, first of all, find the intent, answer the question in your document base, your FAQs effectively to do that. But that's just phase one. Because what you find is many questions are not answerable just by a document. They need a query. If you call into the help desk and you say, what's the status of my trouble ticket? It can't answer it with a question in a document. It has to run a query. It has to know who you are. It has to take those parameters. It has to call the function. It says, oh, the status of your ticket is XYZ. The most similar tickets are resolved in 2 hours, right? We have this power of similarity in AI. And so you're going to run a query. And the whole thing about that is, as a product manager, your job is to give people as much information as you can without hallucination, right? That's a big problem, without making up fake answers. And try to put them at ease because you know about similarity. The bottom line is so much of generative AI is to really understand that in the past, computers were really good at counting things and summing things. We call it the counts and amounts world. OLAP cubes, right? For quickly adding things up and giving you the total sales of this store of this product on this day, right? But AI is not like that. AI is not about counts and amounts. It's about finding similar things, similar answers to similar questions, similar words to similar phrases, similar questions to queries, similar parameters inside your question that are passed to those things. And that similarity is what's driving AI. And so product managers have to have this intuitive sense that your team has to master similarity in order to build intelligence into your AI products. And it's not just similar in one dimension, it's a holistic view of similarity. And that's really what a lot of my blogs talk about is how do you get to this age where product managers can have an intuitive feel. And by the way, got to do it in a fun way, right? You can't just throw, here's the math equation out to your product manager. That's not going to work. So I have lots of stories out there. I grew up in southern India. I was a big fan of Rudyard Kipling, and I have some stories I called Mowgli's Walk from the Jungle Book. And Mowgli's Walk is a fun story about Mowgli in the village with a wall. And Mowgli's walking down the trail, and at home Mowgli has a beautiful orange kitten, and it's very friendly. But when Mowgli's walking down the trail one day, he sees a tiger. And immediately in Mowgli's brain, Mowgli has to decide, is that tiger like my kitten, friendly and fun, or is it a threat? And we have about 100 milliseconds to make that choice in our brain. Our brains are wired to compare things and do that quickly. And that's what computers suck at, right? They're terrible
Yes.
at comparing things in the past. And so we're trying to go down this path where we can tell stories like Mowgli's Walk to give people an important idea that similarity, not just similar visions, similar texts, similar documents, similar paragraphs, similar queries, all that similarity has to be done in your core competencies to build generative AI products around your old classical counts and amounts OLAP cubes.
Got it. I have a one thing that resonated a lot with me is the things not strings. I know you were mentioning that Google wrote that back in 2012 or something like that, right? So this goes back to that concept, I believe. So we understand the intent of what the customer is trying to do rather than trying to understand the string that they gave it at that moment of time.
Yeah. Yes. Yes.
Yeah.
That Things Not Strings was written in 2012, right? And if you
Okay.
go to DB Engines and you look at the popularity of knowledge graphs and graphs, it really started to take off in 2013 and 2014 because companies around the world realized that at the heart of Google search was graph, right? And
Yes.
they said, gee, if Google is doing this, it must be cool, right? Now, not a lot of companies are still kind of stuck in what I call the era of card card readers and card punch and punch cards, where they try to force data into tabular systems, right? But the brain doesn't have tables in it, right? Intelligence is not about tabular data. We need to have structure. We need to understand relationships, and the connections between an intent and an answer has to be at the core of everything we do in AI. And I think slowly people are starting to realize that. And that's why I work at a company that does nothing but knowledge graphs and scale out graphs. So I think it's the future. I think it's going to take people time to realize that it's not a technology that big companies or small and medium companies are going to pick up overnight. They have to have product leadership. They have to have architectural support. They have to have a clear executive sponsor. And if they have those things, then they'll move down that generative AI and knowledge management space.
Yeah, Dan. So yeah, I think we'll dig deep into more of the anatomy of all of these Gen AI products and chatbots and also graphs and all. But even before that, right? For anybody who's viewing this and wants to understand stuff at a basic level, how do you define AI?
Oh, that is a good question. I wish there was a simple answer. And I think the first thing is that it's not a static definition. It's not something that is going to be the same last year as it will be next year. It constantly changes. And my best example is Alexa, right? And I'm sorry if I'm setting off everybody's smart speakers right now, but if you understand that smart speakers, at one time, everybody thought that's AI. It can recognize my speech, right? That was a very, very important step, and everybody thought that was cool. And now smart speakers are just kind of like, oh, that's just part of my thing. We use it every night to set the timer for cooking, right? That's about it. So what was AI back then is no longer. It's just part of the environment now. What about generative AI? Well, we know that generative AI was just amazing when ChatGPT came out. Everybody thought it was very cool. And then they start to realize, wow, this isn't Savior. It doesn't really understand what I'm asking. It's just mimicking. We call it the semantic parrot. And so today, Gen AI is considered AI. But in the past, that'll just be, well, that's a dumb chat bot that's going to, generate some code for me or do something like that. Now, what's really AI is going to be intelligent agents, right? Can we build agents that traverse all of our networks, gather the information, bring it together, and work on a problem on its own until it comes up with either it exceeds its budget or it solves a problem for us? That's going to be AI in the future. So it's a constantly changing field. and what's common to that is it's becoming more about the way humans work. But I just want to just be very clear. Generative AI is not really true artificial intelligence at all, right? It is just predicting the next token. That's all it is. It's just a big neural network that predicts the next token. Generative AI systems don't have what we call a model of the world. If you ask me what a real definition of AI is, it's systems that have a realistic model of the world around us, and inside it, they manipulate that model to help us understand things and make predictions about the future. Right? So if you don't have a realistic model of the world, it's just a mimicking, it's a parroting thing. And that's what we're looking for. That's what we're trying to do. We're trying to build highly precise models of the world in our computers so that when we ask it questions, it knows how to run queries on exact models of the world to make stepwise progress at solving complex problems.
So essentially, would you say this is mimicking the human brain, the way we have synapses and the connections between them, and the stronger the connections, the better you can understand stuff, relate stuff, and the closer AI gets to mimicking the human brain is. Do you think that's the ideal definition for AI?
Not exactly. I love studying the human brain. One of the most important books if you want to understand intelligence is to read Jeff Hawkins' book called The Thousand Brains Theory, and he also wrote on intelligence. And I have several blogs about those, and so I encourage people to just go in and do a deep dive into some of Jeff Hawkins' work. And what Jeff really does, he's the premier architect of the brain, right? He's not interested in the chemistry of the brain. He's interested in how the brain works and how all the pieces, high-level pieces, fit together. And what Jeff Hawkins has, the theory that he has, which is pretty well accepted, is that our brain has what are called about 150,000 what are called cortical columns. And those columns are layers of neurons that are connected. But what they do is they take input data, they transform that data similar to how a neural network does. And then each of those columns come out with a voting system, and they vote on what they're seeing or what they're hearing or what they're understanding. So it's 150,000 little things in your brain that vote on what they think is what is happening in the world, and then also voting on where it is in the abstract models. Our brain has all these abstractions of models. I would say today's neural network is not anywhere close to that, right? It's inspired by it. We call it brain inspired, right? When we look at the weights in a neural network, those weights are kind of like the weights between neurons. But the architectures, remember, we have about 62 billion neurons in our brain. But for every neuron, we have 10,000 connections, right? Almost all of the knowledge graphs that I work on, each vertex has about 5 relationships, right? So 5 connect relationships versus 10,000, radically different. By the way, most of those are very weak links, right? And they're not hard links. But what we're doing is we're slowly moving towards architectures that are converging with some of those things. The way our brains look at similar things and make analogies and metaphors, we're also seeing neural networks that can kind of mimic that.
The brain is very, very energy efficient, I guess, right? Compared to all the neural networks.
Oh my God, yes. 20 watts, right? If you think of a very, very low-powered light bulb, 20 watts is about what our brain uses. It is amazing how much energy we take. There's stories now that some of the AI companies are trying to go out and sign long-term 10-year contracts with power providers, thinking that they're going to have they'll spend trillions of dollars buying GPUs to train these networks. Oh my God, that's just crazy. Yes. So I'm quite skeptical of you can just keep making it getting bigger and bigger. I think we need better algorithms, and I think we will get better algorithms, and we see lots of signs. GraphReg being a really good example of, by being a lot more clever, we're going to get much more usage out of much smaller computer systems that have precise models of the world. So anyway, I could go on for that for a long time, but there's a lot of good books out there on brain, and biomimicry is a really good thing. I always try to be inspired by reference frames. Reference frames are the way that Jeff Hoggins perceives that you take data and you transform that. You kind of rotate around the world. You're transforming it constantly, looking at it a new angle. And that's really what neural networks are doing too. They're taking data, and each layer they're transforming it into a different higher order space. And then it's easier for them to do analysis when you do that transformation. So it's great to understand reference frames. Whether we can really put that into place and make a practical product today, not yet. Maybe 5 years from now. So,
5 years is still a good time frame, I guess. Yep.
here, my bet's still 2029. I think by 2029,
Yeah.
about 5 years from now, we will have computers that are going to really be powerful at solving problems that almost all humans could do, and they can do that autonomously on their own. And you just need to give them guardrails, right? That's the important thing, that they don't allocate too much. I build the largest graphs in the world. Some of the graphs that I build run on 50 different servers, right? Can you imagine one rogue query going and doing detailed stuff on every server of those 50 servers? Man, it would take up a huge amount of memory and RAM and all this other stuff. So everything we do, we have to put guardrails around. Otherwise, these things go wild. So it's not just a question of can you do it, it's can you do it responsibly, and for every agent, can you put a budget of time and memory and power, maybe even. You can only use your power budget of this, and then you have to give up, right? If we don't have those guardrails, we won't be able to build these things. And I've been in many big aggressive data lake projects, and they can't control rogue queries, and so they have to be shut down. So
That makes sense.
uh,
2029 sounds both awesome and scary.
yes, it is.
I have a question on agents. So, I mean, I'm generally familiar with the concept, but would love to understand your thought process there. Like, in general, if you're thinking about generative AI, like you said, it's predicting the next words that humans gonna talk, or next words that the humans gonna generate. But agents, like you said, are way more powerful because they would actually do the work and continually predict what's going to happen next. Can you talk more about let's start with basics, at least for the audience, right? Like, what are the agents? Probably can you give us a couple of examples of like how they can actually solve human problems?
Yes. Well, let's start out with a really simple definition. And the definition that's very fun and easy to understand is when you have a task and you let the large language model do planning on that task, right? Instead of an algorithm where you say do step A, step B, step C, you have the large language model do the plan, right? You say, here's a complex program. Please break this up into 10 pieces, and you pick what those 10 pieces are, and then I want you to work on those separately. I do this all the time when I teach a class called microsims. Microsims is mini simulations of classroom problems that teachers are trying to build agents for, and we build graphic animations for geometry and math and physics and chemistry and stuff. And so one of the first things that we teach the teachers to do is how to write a prompt that will ask the large language model to decompose a problem into pieces, right? So it's decomposition is really what we're teaching. And the start of agents really is understanding decomposition, as how to break a problem into things. It gets much more complicated after that. So if you ask a large language model, break us down into 10 tasks, it can do that, and it can try all those, and it can do it. But what if you have tasks that are dependent on each other? What if you say, create a vacation plan for me, and I want you to do car and hotel and plane and dinners. Oh, and my budget is $1,000. Right. Well, then it has to go out and try to balance those things to make sure it goes under your budget. Right. So tasks are interdependent and have to be retried. So you see this; these are iterations and loops. Just to make sure everybody knows, you may be using this today and not realize this. If you use ChatGPT's analytics tools and you say, upload a CSV file and you say, go figure out what this means, it doesn't respond right away. What does it do? It spins and it says, reading the data. And it says, I've found the first row has metadata. And then it says, here's the meanings of it. And it says, oh, this looks like a customer survey result. Oh, we have standard ways of doing this. And then you say, what are the anomalies? Right? That's, oh, yes. What are the anomalies? Oh, it looks like all these customer surveys were really good, except for last Thursday where your net promoter score dropped. That's an anomaly. It figures that out. I don't have to ask it, go look at Tuesday. It just figures that out. So it has these agents. Now, what's important about these agents is that what they're really doing, and by the way, it generates Python code to do all this, right? You're aware that all of these things, it's generating these little Python code in the background and getting results. But what it's doing is it's really matching a workflow, right? It has this database of workflows, the common questions that people ask. Here's a CSV file, go figure this out. And it knows to do a metadata analysis of the first column of the CSV to see if it has row headers in it. It's just matching a workflow, right? And then it goes through that workflow. And if it works, it goes on to the next step, right? So you're already using intelligent agents when you use the analytics features of ChatGPT. And what's important about it is to understand that large language models today are single pass, right? You give it a prompt, it returns something. And agents really are multiple passes, where you give it a small problem and it goes and works on it independently. And it can look up documents, it can call a database, it can compile code, it can run that code. Those are all little things that agents are doing today behind the scenes to solve those problems. And what we're going to start to see is I think that came out last fall on ChatGPT.
The plugins.
Other companies haven't really caught up to it yet, but they're starting
GPTs.
to do that. And then what we're going to start to see, it's going to be more pervasive in these products. And what we're working on right now is, I fundamentally believe that there's a new language out there called GQL, the graph query language. It's far more mature than any SQL or Cypher and all that stuff. And I believe that in roughly a year from now, intelligent agents will be able to create very, very sophisticated graph pattern matching queries. No agents can do that today. They can run simple flat things and lots of things with Python data frames and very simple flat data, right? But you ask it to really understand patterns and communities in a graph, and they fall over, right? They don't do that. In a year from now, we will have intelligent agents that will load documents, find all the things in those documents, the people, the places, the things, the location, the events, the concepts, the abstractions, the sentiment, and then do graph queries on those documents and come up with really, really good insights. So we have very, very exciting things. I think every product manager in the world should be playing with ChatGPT on a regular basis just to see what new features it has. So I'm very excited about how product managers can use that in products in the future.
Yep. Even on personal life, right? I literally use it on an hourly basis nowadays. Like
Yeah. I tell people I'm kind of addicted to my ChatGPT, right? I couldn't go through a day without it, to be honest.
nowadays any question that I have, I'm just casually chatting with it. I'm trying to do this. What do you think?
Yeah.
This is what I put together. Like anything you can add. Recently, I was
Give
on
me
a vacation.
some concrete examples of what you enjoy doing with it.
Yeah. So recently I was on a vacation and I was in Europe actually. And not all the days I had a good plan. We had some plan laid out to say these are all the things that we did. One day we went to one location and we were like, hey, these are the 6 things that we want to do. fun part was like as soon as we went there, those four of them were like 1, 2, 3, 4. Right, you just standing there and four of them are done. Then I didn't know what to do. Literally just went to ChatGPT and said, "Hey, I'm in this location. I looked at all these places and I have 6 more hours left. Give me an itinerary of what I need to do." He gave an itinerary, and then I said, "Hey, I need an hour break here so that I can go back and do something." Iterated perfectly, gave an exact schedule, gave the exact links on where I need to book things and stuff, what I need to be prepared. I was like, dude, this is amazing. Otherwise, I would have wasted like a couple of hours at that point of time figuring out, researching websites. Yeah.
Yeah.
And
Are you using it for any work-related things, or
So on work, same things. So especially as product managers, right? We do research, the first thing to begin with, and then we write like PRDs, product requirement documents, to say, hey, these are all the things that we want to do. Then another big piece of our work is like communications, like
Mhm.
these are the products that we are building, this is how we are launching, etc. So at each of these areas, I literally go to ChatGPT and ask, hey, this is what I'm thinking about. Is there anything else in the world that has implemented similar things? Give me
Yeah,
some examples.
wonderful,
For
wonderful.
example, I will give you another very clear example. So recently we were building an integration with labor management. Okay, I went and asked, hey, give me a couple of big companies that use labor management. Gave me those. Okay, let's pick one of these companies and give me the APIs that they currently have so that I can integrate. It gave me a list of APIs. Then I said, okay, within these APIs, can you help me create the corresponding entities? And it gave me the entities. Then I said, okay, let's think about top 5 companies now. And then let's try to make it generic on all the entities that I need to create. It gave it. This could have taken me a couple of weeks to
Yes,
figure
yes.
this
figure out.
out and make it right. Now all I had to do is, once it gives it, go back and validate. That I could do in a couple of hours. Yeah.
Yeah,
Very good,
and
very good. Sid, do you
I
have some
think
stories for us?
yeah, I have some stories, and I think it's like the one thing, right? Funny thing is like I keep my bill on subscriptions keeps going up as more and more AI tools come in. So now I'm using a lot of AI tools, right? Paying for them, but I think specifically, right, all of these tools are really good in different ways. I use a lot of Perplexity for search. Previously, I used to
Hmm.
use Google, but Perplexity is really good at
Wonderful, isn't it? Yeah, yeah.
answering complex queries, and that's
Yes.
one of the tools in my bag. And I use Claude a lot for content editing, so
Hmm.
I write a newsletter, and it's really good with writing content and helping me do all of that stuff. And I
Yes.
use ChatGPT for rest of all the stuff, financial my financial analysis and all of that stuff. And there's also a GPT which I created for my newsletter, which basically I trained it on all the newsletter editions, and it'll actually
Oh, you
anybody
did.
who,
Good for
yeah,
you. That's great.
yeah, I just launched it like a couple of weeks back, and anybody who has any questions, it actually gives a smart answer and refers them back to my newsletter. So yeah, happy to share that.
You're all over.
But so I'd say, right, like even in the company level, I think this will also get us to the next question, which I was saying is a lot of companies have different views at using AI tools and encouraging tools. At our company, they are very open, and they have a clear rubric on like what tools can be used, what cannot be used, and how. And they are also encouraging us to do it. But so, how would you say like AI in a company culture, and how should organization basically approach this challenge?
Yeah, it's a complicated question, and every company has different concerns. And I'll put the concerns into three buckets. One is legal, right? If we use generative AI to generate this, is it legally put it on our site? And even though humans edit it, what's the concerns there? The other one is security. Are we putting our proprietary knowledge in the prompts and teaching these products about our internal systems? By the way, every system has a way to opt out, and you just need to know how to opt out so it doesn't steal your prompts. Even the most general ChatGPT does it. If you're using Hugging Face, also they are governed by a lot of the rules in the EU, so they can't store your prompt history. You're protected by a lot of the EU regulations there, but you do need to be aware. If somebody sends you a random link to something, they may be harvesting your prompts for knowledge. And the third one is responsible use. Are you generating text that has bias in it? And are you checking it for bias and things like that? I wrote a blog that was a really fun but scary blog on how incredibly biased the early BERT models were. What you did is you force a pronoun, he, she, and then you put an occupation in. And what you find is that when you use a word like president, it often uses a he. And if you use nurse, it often uses she, because that's what it was trained on. But when you start to say, generate an image of a CEO walking down the street, OpenAI had to work very, very hard to look for roles and then randomly put in gender and race and other things to do that. And they spent a lot of time writing those interceptors and putting forced roles and things to make it less biased. So they're aware of that. These companies that have public images, they have to make sure that they're trying to minimize bias. You'll always have bias in these models. So those are things to be aware of. I think every company should be thoughtful about those three things: the security, the responsible use, and loss of intellectual property, and bias. But what to balance that is the productivity of your employees, which you are just talking about, right?
Yes.
Huge productivity leaps. I would say that most companies I work with, their employees should go through a 1-hour training session on how to responsibly use generative AI. That's it, about 1 hour. I've worked in companies where they completely shut off all access to ChatGPT when it came out. And then, of course, there were 10 other things, and then they couldn't predict them all. So basically, they were forcing their employees to use bad generative AI by their policies. And there's what I call the FUD factors: fear, uncertainty, and doubt, right? Where a lot of the executive leadership, they're completely running in fear. They don't understand these models, and they don't know how to train their employees to use them effectively. By the way, OpenAI, if you have a corporate account, they guarantee that they will never use your data for training. So, if you really have concerns, you just get a corporate account for that, or these other models. So it's a balancing act, right? You have to balance the risk and the reward. And what the three of us, I think we all agree, is the rewards are huge, but you can't ignore the risks, and you have to put in places to mitigate those risks.
Yeah, I think you hit the right point, Dan. So, like, a lot of people have, are in this gray area, whether, in some companies where company doesn't have a clear stance whether to use it or not use it. So they basically tend to use it anyway, and they use the wrong tools, right? So I think that's where, any policy that could help guide their employees to use it in the right way would make it more efficient and effective. And also, I see a wrong notion of some people saying, is writing code with AI cheating? And one of my friend was saying that one of his co-worker was saying, it feels like cheating when I use AI for coding. But I don't know, like, if you how are you moving your lawn? Are you using a lawnmower, or are you doing it by hand, right? So I think
That's a great
technology.
metaphor. I love that metaphor. If you have a scissors, you're doing it by hand. If you have a lawnmower, is that cheating? No, that's being effective. That's being productive. That's using your time wisely so you can work on solving the hard problems in our world. And we have many hard problems to solve. So
That's right.
I want to go a little bit more deeper into the business value as well, Dan. Like you were mentioning, right? When you are running one query, it's probably running on 5 different servers, like using huge amount of RAM. So how do you go about thinking, like, what is the business value that you're generating for a specific model that you created for the company?
So a lot of my work when I was at Optum, I ran the Generative AI Center of Excellence, a COE. And what I did is I developed some pretty sophisticated taxonomies of how people were approaching these things to try to find the best business value. And I always think of two taxonomies running side by side. One is, what are the types of problems people are solving? And the other taxonomy is, how are they solving these problems, right? And those are separate things. In healthcare, one of the best examples is what we call prior authorization, for example, where somebody has an expensive procedure or a drug, and they want to make sure that you've tried the lower cost options before you did that. Well, when you sign up for this, what they need to do is they need to go through a chart and figure out, if this is a drug that costs $1,000 a week, did you try the $100 a week drugs already? Right? And that should be in your chart. And so you fill out this form, and an AI has to go through and look at all the prescriptions you've tried. And if it sees a similar one that has done that and that didn't work, and maybe you had bad side effects or something like that, then you would authorize it. Well, we can measure exactly how much time it takes a human to look through your chart. We can also measure the time it takes for a generative AI tool to go through your chart, and specifically not just say yes or no, I'm going to grant this, but specifically say, I did not see the evidence for this, or conversely, I did see this. And about 90% of the prior auths, a physician does know the background. 90% of them are positive, they go through. And you can highlight the evidence, right? You can explain the evidence. So when we look at business value, we are always comparing an automated system with a human being. And those human beings have a dollar cost per hour. And so we can very easily see this. Now, we have to realize that generative AI is not perfect. There's always problems. And so we always have human in the loop in a lot of these things. But in general, one of the projects I've just recently working on is we have an hour-long call with customers, and during that call, we make promises and we give homework assignments. And at the end, we can measure the sentiment of the customer on those calls, right? So by recording those calls, we can, if you couldn't attend the call, you can get a summary. That's great. That saves a huge amount of time. So you don't attend meetings you may not have to be. That saves a lot of time. We get a very detailed list of homework assignments and promises made, and often who they're assigned to, and we get a sentiment score, right? That adds value, right? How do you put a dollar value? That's kind of hard, but these call transcripts, they're getting the sound quality is better, the transcripts are more precise, and generative AI can do more things, and they're much more cost effective. So just when you go through this business value calculation, there's a lot of abstractions. You have to make sometimes guesses about what is the value of not attending a 1 hour meeting when you were only there for you only needed for 5 minutes. Well, that's going to save you 55 minutes of productivity, right? That's the value of adding a summary of that call, right? So there's lots of ways to go and do this, but I think what you're finding is that good product managers are very detailed in asking what's the total business impact of an application, not just one dimension, but the dimensions of other people around that product. And part of that is what's called stakeholder analysis, right? Who is all the stakeholders in a call with a critical customer? And how do you make sure that all the stakeholders we understand what the impact of this technology to those stakeholders are? So
Yep.
it's hard to do.
Actually, yeah, I mean, if you think about business internally, I think it's still a much smaller benefit value. Like if you think about operations benefits or customer support, etc. But especially when you think about like tools like ChatGPTs and others, the amount of productivity that they're giving to the end customer is humongous. So if I think about myself, the example that I gave, right, my tour plan, it's just me, one person doing it. But if I think about millions of people probably trying to do the exact same thing, and probably them using a lot of mediators to come up with this plan, etc., it's a humongous amount of time savings that like multiple layers of people could get.
Yeah.
That's right.
Yeah.
Yeah. We have, thanks for going into so many details about all of these things, Dan. So, no, there are what are the key types of AI and Gen AI, and like, what are these two different taxonomies, right? Could you go into some details there?
Yeah, I think first of all, it's the types of problems that Gen AI is solving. Almost all of them are related to conversations. And I work in the text world, right? There are other Gen AIs that generate images. You can actually generate synthetic sounds also. They can generate synthetic music. You can say, do some music that's reminiscent of electro dance music for a background and has these themes, and it'll do all these things there. It's just truly amazing. Most of my work though is with text, and so that's really where a lot of my taxonomies do. When I look at the first taxonomy of the types of problems that we're solving, I think chat is the one that comes to mind, right? And what's important about chat is that it diversifies into many subtypes of chat. The first one is something like ChatGPT, which is general knowledge chat, general public knowledge, right? ChatGPT was trained on public documents, not private documents. You can't ask ChatGPT about what the status of your customer inside your firewall is, right? So the first thing we divided is chat bots that don't just ask general questions, but they ask specific questions about what's going on inside your company, right? And the question is, how do you get that knowledge into the chatbot, right? Because it took $100 million to train it. You're not going to fine tune it. Most people don't have the good. So the answer there is, what you do is you can take a question and you can find snippets of the most similar things inside your knowledge base, inside your things. And because we talk about AI is about finding similar things, you include those facts in the prompt. We call that prompt enrichment. And then you get an answer that really kind of answers things about internal. So chatbots for general, chatbots for inside your internal knowledge base. And then you can also do that same thing with search, right? Search is another branch of that. Search is like Perplexity, where you're actually using generative AI to make better search experiences. You can do that same thing for internal documents, right? And what do you have to do? Well, you have to take all of your documents. You have to chunk them up into fragments. We call that semantic chunking. Each paragraph, for example, is a logical thought. You create an embedding that puts that into a multidimensional space. And then when you search, you're going to bring not just the document, but you're going to bring focus on that one paragraph as one of the search results, right? So the same things we use to match chat questions with answers, we're also using as a search retrieval. Searches are often just short keyword questions and things. And then so we talk about chatbots, we talk about search, and then we talk more about more complicated things, and that's the whole world of agents. And that agent is a whole taxonomy in itself. And there are agents that do very simple things. They just break things up into tasks. There are agents that know how to call APIs. There are agents that know how to create SQL and execute those SQL. There are agents that are very good at taking questions, matching them to a query, extracting the parameters, and then calling that, and then bringing it back, and then formatting it in a pretty table or graph or whatever. And so that's roughly the space of the types of applications that we're building. What problems you solve is going to be very much dependent on an industry. I came from healthcare. They were looking at patient charts. They were looking at coding systems. They were looking at call centers. People are asking what's covered by their benefit plans, and it has to match their questions specifically to a paragraph in the benefit plan. Prior authorization, all the other things that look into patient charts and try to do summaries. Writing letters now. There's this big AI war going on between when you get denied of a claim. There's AIs that will automatically with the physician to re-ask them to do that. And a lot of there's legislation that if your claim is denied, you have a right for a human being to meet with you for 40 minutes, 5 minutes to do that, right? So it's because it's automated, the ways insurance companies are just falling apart because they have so many auto bots that are requesting claim denied things. A lot of times it was so much paperwork, the physicians would just say, I'm just not going to request this. It cost me $300 to do this procedure and I got reimbursed for $200. And now what they're doing is they're pressing a button that says, I'm going to file a claim that wasn't getting claimed in my plan. So we're starting to see a lot of automation wars going back and forth, and that's only going to continue, right?
Yeah.
So.
Yeah. Thanks a lot. I know kind of if I pick some nuggets out of the use cases you were mentioning, chatbots helping employees or external users, maybe enterprise search could be another solution. Call centers could be another way where you can use GenAI and all of that stuff.
What are the challenges do you think we should solve for GenAI before we try to use it to solve it?
One great story is ask your favorite generative AI engine how many times the letter R occurs in the word strawberry. And I think the answer is none of the engines can do it. They'll all guess 1 or 2 or something like that, right? Well, the reason is they're not trained. Nobody has asked that question in their training set. GenAI is not like a rules engine, right? It is extremely difficult to test, and there's always a chance of getting hallucinations.
Could you maybe give us some insights on what are the problems you're trying to solve and how are you trying to further the whole GenAI ecosystem forward?
There are many types of graphs in the world that work on a single server. They assume a flat memory space, so all relationship traversals are pointer hops, and there are dozens of those, and they're very low cost and effective. TigerGraph is different in that we assume from day one that your graph has to span dozens and dozens of servers.